All right, let's go ahead and talk a little bit about 3.3 and 3.4. So 3.3 is solving absolute value equations and absolute value inequalities. So let's talk about the absolute value equations first. So when we're solving absolute value equations, we need to understand, first of all, what absolute value is. All right, so just to make sure we're all on the same page, absolute value is the distance a number is away from zero on the number line. Okay, so a distance, when we think about distances have to be positive, right? Because if you say I'm going to go run, 5 miles today, you can't say I'm going to go run a negative 5 miles, right? Distances have to be positive, right? It doesn't matter if you're going backwards or whatever, you're just making the running harder, but it still is a positive number. Distances have to be positive. So when we're finding the absolute value of a number, that means our answer to an absolute value needs to be positive. So if I was asked to find the absolute value of -3, you'd be thinking, well, how many places away from 0 is that on the number line? Well, -3 is 3 places away from 0. Right? And then also if I said, okay, well, what's the absolute value of +3? Well, +3 is still 3 places away from 0 on the number line. Right? So the answers to these always end up having to be positive. The answers to an absolute value are positive. Okay? And so we're going to be solving absolute value equations. And let's just take a look at something like this. If I said, what's the absolute value, the absolute value of x equals 2. Well, this is saying that x is 2 places away from 0 on the number line. So if I'm thinking of a number line here, right, and 2 places away from 0, well, if I go to the right, +2 is going to be one of my answers, but also -2 is also 2 places away from 0 on the number line. So 2 and -2 would be my answers there. Okay, so just make sure you're understanding what is, what we're meaning here. And then maybe, thinking about this a little bit more, if you were asked to find, what's the absolute value of x equals -5, well, again, we cannot say that, we can't go -5, units away on the number line, because this has to be a distance, and so the absolute value can't equal a negative number. So when you have something like this, then it's a no solution, or sometimes the homework writes it as D&E, does not exist, or sometimes you'll see the little empty set symbol on that. Okay, so all of those things would be a way that we could say that there is no answer for this, because an absolute value cannot equal a negative number. All right, so let's take a look at an example and just make sure that I looked through the quizzes that you guys did, the little mini quiz, and then the homework and stuff like that. There was one like this that wanted to talk about. Seem to be giving some people some problems. So if we have 5 minus 2 times the absolute value of 3x minus 4 equals negative 5, right? So right now, we don't have our absolute value by itself. So at this point, we couldn't just say that this does not exist because we don't know for sure. We first need to get that absolute value part by itself. And so we have this 5 and we have this negative 2 here. And so we need to think about what we need to do with this. And let me just point out something that a lot of students try and do is when they see this 5 minus 2 out in front here, they think, oh, I need to, do 5 minus 2 first. But that's not what you're doing here. We're trying to solve this to get the absolute value part by itself. So think about if I had, 3x plus 5 equals negative 7, right? Well, the first thing that I would do is subtract the 5 over, and then the last thing that I would do is divide by the 3. So it's the same kind of thing that's going to happen here, right? But, so we got to think about, okay, what needs to be added or subtracted over first, and then what needs to be multiplied or divided over. So this 5, right, it's a positive 5, so we're going to subtract 5 over to the other side. That would be our first step. When we do that, right, that just goes to 0, which is what we were trying to do, so we could get the absolute value part by itself. Then we're left with negative 2 times the absolute value of 3x minus 4 equals negative 10. All right, now this is connected by multiplication, right? Negative 2 times this, so I need to get rid of that negative 2, so I'm going to divide both sides by negative 2. And when I do that, right, those divide out, and that leaves me with the absolute value, absolute value of 3x minus 4 equals positive 5. Okay, now let me stop there for just a second and make sure everybody is with me and see, if there's any questions that I can answer up to this point. So just remember that you're undoing those order of operations, and what you're trying to do is get the absolute value, right, by itself. Okay, and now that's what we have. We have the absolute value alone. There's no other, there's nothing out in front that's being multiplied or divided by it, or added or subtracted to it. So now, remember up here when we talked about, there's two different numbers that would give us the same answer, right? That gives us 3 in this case. Negative 3 is 3 places away from 0, and 3 is 3 places away from 0. So when we're solving this equation, we've got to check both the positive and the negative on this. So we're going to write out, it's really important that you remember that when you have absolute value, you've got to write out 2 different equations. The first one is going to just look like what we have, just without the absolute value. So it's just going to say 3x minus 4 equals 5. Where the other one, I'm going to keep what's inside the absolute value the same, 3x minus 4, but then I'm going to put it equal to negative 5. And you could, on some videos, they might show you to, make the 3x minus 4 all negative and keep the other side positive, right? And that works too. There's more chance for mistakes, I think, with a lot of people. And so, so that's why I just leave, 5, positive 5, and then the other one is going to be negative 5. Okay, and then we're just going to solve each of those 2 equations for x to see what our answers are. So let's add 4 over. So 3x equals 9. And then let's divide by 3. So x equals 3 is one of my answers. And then the other one, again, we're going to add 4 over. So I get 3x equals negative 1. And divide by 3, x equals negative 1/3. Okay, so these are my two solutions here. And if I put those numbers back into my original problem, I could check them to make sure that they work, right? So let me just do the 3 first of all. So if I put that back into the original, write down the original one first here. So 5 minus 2 times the absolute value of 3x minus 4 equals negative 5. All right, so I'm going to put 3 in place of where my x is. So, and if I wanted to check my other one, I'd put negative 1/3 in there. All right, so I'd have 5 minus 2, absolute value of 3 times 3 minus 4 equals negative 5. So I'm trying to see if when we're checking that I get, the left side of the equation equals the right side of the equation. So again, if I'm simplifying this up with order of operations, I need to do what's inside the absolute values because those are kind of like parentheses. So I'll have 5 minus 2 times the absolute value of 9 minus 4 equals negative 5. Well, 9 minus 4 is 5. And remember, this is connected by multiplication there, right? 9 minus 4 is 5. The absolute value of 5 is still 5. But then I need to bring down the rest of this. All right, so I need to do my multiplication before I do my subtraction. So 5 minus 10 equals negative 5. Negative 5 equals negative 5. So that one checks out. All right, like I said, if we put negative 1/3 in place of x also and did that, we'd see that that checks out also. All right, so both of these are good answers. 3 and negative 1/3 will be my answers. Okay, what questions can I clarify? What questions do you have? Can I clarify there for you? Everyone okay? All right, let's look at one other absolute value equation, and then we'll move on to the inequalities, because it seems like the inequalities are where there tends to be a few more questions, right? Yes, so Brittany, so you should get 2 different answers, and that is correct. For absolute values, you should get 2 separate answers, okay? Sometimes, and that's not going to happen right now, but sometimes you could get one of the answers doesn't check out and one does check out. Okay? But on these are going to work out. So, but yes, you'll come up with 2 different answers. Okay, so let's look at something like this. So if you're asked to solve the absolute value of 3x minus 1 equals the absolute value of 2x plus 4. So here we can't really get the absolute value by itself because both sides have an absolute value, right? So when you have both sides have absolute values, we're going to start right off writing our 2 different equations. So our first one, I'm going to keep my left side exactly the same, and well, in this first equation, both of them just come out of the absolute values, right? They're exactly the same. But when I make the second equation, this is where a lot of people tend to miss things, so watch closely. So one side of the equation we need to leave the same, so I'm going to leave that 3x minus 1, right? It just comes out of the absolute value. But the other one, the other side needs to be made negative. So really what you're doing, it's like you're taking a negative 1 and you're timesing it by, let's see here, by what was inside there, because I have to make the whole thing negative, right? So I'm distributing a negative through on there, okay? All right, well, I'll just solve this, the second equation first here. So let's go ahead and do this. So when I distribute that -1 through, I get -2x and then -4, right? Notice that the signs on both of those change here, okay? So be really careful with that. And now we're going to get our x's on one side. So I'm going to add my 2x over to the left side. So we get x minus 1 equals -4. And then I'm going to add my 1 over. So x equals -3. Okay, so there's one of my solutions. Now let's figure out the other one by solving the other equation. So go ahead and solve that one down and see what you come up with. Wait a minute. Oh, I did something totally wrong there, guys. Good, I put plus 2x, and then I didn't add it there. I subtracted it for some reason. Hold up. That is not right here. See, something crazy can always happen here to us. Let's see. So I'll get 5x minus 1 equals -4. And then I did add 1 over. So I should have 5x equals -3. But then I still need to divide by 5. Right there. So I should get x equals -3/5. All right. Does that look better to you guys on that one? Sorry about that if you guys were working along there. Right. Hopefully you didn't make that same mistake that I did. All right, then let's do our other one. So I'll subtract the 2x over. So I should come up with x equals 5, and so this is not the answer here, right? It's this one. And x equals -3/5. And when you write your answer in on your homework, it's just going to want you to, say which one number is and then separate it with a comma to say what the other answer is. So when you put it into your box that you're typing in, you just will put it in like that. You don't need to put parentheses around it because this isn't an ordered pair, right? You just want the answer separated by a comma. Okay. All right, well, let's look at the absolute value inequalities next. Right, so with absolute value inequalities, when you see that word inequalities, you should be thinking of, it's not equal, but when things are not equal, these inequalities really mean that we're talking about like less than symbols, less than or equal to, right? Or maybe greater than and greater than or equal to, okay? And so I want to talk about these, and there is just kind of a way that I have to help you remember what you're trying to find here when we're solving these absolute value inequalities. So remember that these symbols that are here first, right, less than and less than or equal to, I want you to think of as less than. Right? It's just kind of a play on words. And it's important because remember this word and, when we talked about it before, meant that we wanted to find the intersection. And that's what we're going to be wanting to do here. So when we have these symbols, the less than or equal to, think of less than And that means that we want the intersection of what we find. When we have the greater than or equal to, right, then I want you to think of it as greater, right, greater. And when we have an or statement, remember that that was the union that you were trying to find. Okay? So this is going to help you to know whether we're trying to find the intersection or the union when we're solving these absolute value inequalities. All right, so let's take a look at an example of one that we might need to solve. So for this one, let's solve, graph, and write our answer in interval notation. Okay, so we'll have -7 minus 4 times the absolute value of 7x minus 2. Okay, so all of that 7x minus 2 is in absolute values, is greater than -31. Okay. So you're going to start off and you're going to solve this really similar to when we did absolute value equations. So meaning, first thing that we want to do is we need to get that absolute value part by itself first. So what should we move over first? What's the first step that we should take on this? Somebody tell me.
Add that 7 to both sides.
Awesome. Okay, so let's add the 7 over. So when we do that, we're now left with -4 times the absolute value of 7x minus 2 is greater than -24. All right, now what would we want to do?
Divide by -4.
Yep, so remember it's connected by multiply. So we got to get that absolute value part by itself, so let's divide. And what happens when we divide by a negative?
The sign flips.
Yeah, so we've got to make sure we remember.
You have to switch the inequality.
Yep, so that inequality sign has to flip the other way, right? So now it's a less than.
I have a quick question.
Yes.
Do we only flip the inequality sign if we're dividing by a negative number?
If you multiply or divide by a negative number.
Okay, so if you're dividing by a positive number, then it doesn't change.
Then it stays. Yep.
Okay.
Yep. The only time it flips, yep, is when you're multiplying or dividing by a negative. Good question. All right, so now we've got the absolute value part by itself. Okay, and so now we're going to look and see what kind of sign do we have here. Well, we've got a less than symbol, right? So I'm going to just kind of show you here, right? So this, right, is meaning, oops, I meant to do that, but okay, less than. All right, so we're going to want the intersection. We want to know where they overlap, right? That's what we're trying to find here. So we are going to still write this out. We need two different equations. So in this case, they're going to be inequalities, right? So two different things here. So the first one, the absolute value comes off. So we have 7x minus 2 is less than 6. Right? So it stays exactly the same, except the absolute value sign comes off. On the other one, keep the 7x minus 2 there, but we're going to have to change that to a -6. But that's just kind of like we multiplied by a -1, which means we've got to flip that symbol the other way. And that tends to be a place a lot of students make a mistake, is forgetting to flip that inequality. So not only do you change the sign, right, from a 6 to a -6, but now it's going from a less than to a greater than sign on this one. Okay, and then we'll solve both of these down rest of the way. Is everybody okay to that point? Okay, go ahead and solve those down then the rest of the way. And then try and graph them also.
I have a question.
Mm-hmm.
Could you set that up as a tripartite?
You can, because it's an and statement.
Okay.
So you definitely could. Yep. All right, so when you graph these, right, we see that we want everything smaller than 8/7 and everything bigger than -4/7. And we want the intersection, right, which means we want to know the parts that overlap each other. And that's going to be the stuff in between, right, here. And so our answer, when we write it in interval notation, it's going to be parenthesis because it's an open circle there. Right? It doesn't have the equal to part. -4/7 up to 8/7, and then parenthesis again because that's an open circle. Right? So we just want the overlap. We want to know what that intersection is. Okay. All right, let's try couple more here. So let me have you guys try this one. I'll give you just a couple minutes to try this out. So same direction, solve, graph, write the answer in interval notation. So 5 minus 2 times the absolute value of 3x minus 3 is less than or equal to 11. Okay, let me give you just a couple of minutes and try this one so you can see if you're getting stuck somewhere or if you have any questions anywhere. All right, from here, get to this point, or maybe you got further than this, but from here, there's a couple of different ways that you could solve it. So I'm just going to keep solving it the way that we did above, where we wrote out the two different statements. Okay, so I'll have the 3x minus 3 is greater than or equal to negative 3. And my other statement would be 3x minus 3 is less than or equal to positive 3, right? So I flip that inequality sign, change the sign of the number to its opposite. All right, and so I could solve these out this way. So let me just keep doing this because this might be what a lot of you did. All right, so I get 3x is greater than or equal to 0, divide by 3, so x is greater than or equal to 0. Is one of my answers. The other one, let's add the 3 over. So I get 3x is less than or equal to 6. Divide by 3, x is less than or equal to 2. So if I graph this out, right, and remembering that this is an OR statement, so I want the union of these, right, and I'm graphing these two out on here. So here's 0, and here's 2, right, so at x is greater than or equal to 0, so it's going to have a closed-in circle, and all the stuff greater than 0 is going to be to the right. And I want the stuff that's less than or equal to 2, so again a closed-in circle here, and this time I want everything to the left. Oops, it's going to do that in a different color. Okay, so then what is my answer going to be here? What do you guys think?
Negative infinity to positive infinity.
Okay, why do you think negative infinity to positive infinity?
Because it's everything.
Yeah, because the union, right, means everything. Everywhere we see the blue or the purple, right, and everywhere we see the pink, or sorry, the orange. Let's see if I can get my colors right here, right? And so it's going to span all of the numbers, right, from negative infinity to positive infinity. Now, if we went back up to this statement here, let me write it back over here. So absolute value of 3x minus 3 is greater than or equal to negative 3. Right? So think about what we said. Well, we said an absolute value always has to end up being a positive answer. So if I know that the right side is always going to be some kind of a positive number, and negative 3 is always a negative number, right? When is a positive greater than or equal to a negative? Well, it's always greater than, right? Positives are always greater than negatives. So that's another way that you could look at this. You wouldn't even have to do this last part here. We could just say, yeah, a positive is always greater than our negative, so we could see from there that our answer would be negative infinity to positive infinity. Okay? If this symbol was going the other direction and it was an and statement instead, then we'd want the stuff that's in between 0 and 2, because we'd want what was overlapping, but that's not what it was asking for. It wanted to know the union, right, of these two. Okay. All right, and then kind of similarly, I'll do one more here. We're going to go past 4 a little bit on this, but I hope that spending that time doing the stuff with the projects will be helpful so that you can get started on that. All right, so again, if I'm solving this, I'd start by subtracting my 8 over. Right. And then I'd need to divide by 2. And so look at what happens here. So now I get the absolute value of 6x plus 4 is less than -2. And now, if I'm looking at this, right, this is kind of where, you know, when you get like a negative on one side of the inequality statement, that should kind of be a red flag for you that, oh, maybe I need to look at this a little bit closer, right? We had a negative, right? It was greater than a negative. Positive greater than a negative, yes, that's always going to happen. But here, we're saying a positive is less than a negative. When is a positive less than a negative, right? That's never, right? Yeah, never, right? Positives are always greater than negatives. So this, right from here, we don't even have to make our two different statements and solve them out. You can, and then you'd see that there's going to be no place that these guys overlap each other when you do that. So this is going to be a does not exist case because it's an and statement, right? Because we have this less than, but there's no place that these two are going to intersect each other. And if you, like I said, if you kept going and doing that, you would see that. But you could see it earlier on and just say positives are never less than negatives, right? Negative numbers always have to be less than positive numbers. So that's just another way that you can kind of look at that. There would be no answer on that, no solution. Okay. Questions on that? Makes sense when it's all real numbers, the negative infinity to positive infinity, and when it's a no solution, when it does not exist. All right. Guys are so quiet today. Okay, let's look at, let's go and look at 3.4 now. And I'm just going to point out a few things on this that would be good to know. So on this one, this is graphing linear inequalities. Right? So these are going to again have has inequalities in it. It means you're going to have a less than or greater than signs in them. Right? So if you have a less than symbol or a greater than symbol, when you graph it, this is going to graph with a dotted line. But if it has the equal to part, so if it's less than or equal to or greater than or equal to, right, has the greater or the equal to part, then you're going to use a solid line to do. You're going to use a solid line when you graph it. Okay, so that's one of the really important distinctions that you have to make on these to graph these. All right, so if I'm asked maybe to graph 6x minus 2y is less than 12. All right, there's a couple of different ways that you could graph it, and just like you want to think about this inequality, like in your mind, think about it as an equation. How would you go about graphing this line, right, if it said equal instead of less than? And the way that I like to do it, but there's more than one way. Sorry. I always like to try and get it into that y equals mx plus b form. I just like this form, and I think it makes it a lot easier to figure out the shading of our graphs when it's written like this. But it's totally up to you on what you want to do. Some of the videos will show you to graph using the y-intercept and the x-intercept and then picking a point to like a test point. But let me show you this way. and see what you think about this. So if I try and get this into the y equals mx plus b form, that means I'm trying to solve this equation to get y by itself. So I've got negative 2y is less than negative 6x plus 12. And then I'm going to divide by a negative 2. So when I'm dividing by a negative, that's going to flip that inequality sign the other direction. Right? So now it's a greater than symbol. So I have y is greater than 3x minus 6. Right? And so now when I go and graph this, right, when I graph this, I'm going to start at my negative 6, as that's my y-intercept, and then from there I'm going to use my slope, right, 3 over 1, so that's rise over run, so up 3 and to the right 1, up 3 and to the right 1. Right, now it doesn't have the equal to part, so it's a dotted line that I need to use on this. Right, so I've got a dotted line. Whoa, looks really funky. Let me try again. Right, so this is kind of what my line looks like. And now I'm not done yet because now I need to shade, you know, one side of the line or the other. And the other reason why I like to get it into the y equals mx plus b form, because it's easier for me to see what the shading is. So it says y is greater than this line, right? So I've got my dotted line there. The stuff that is greater than it is going to be the stuff that's above the line. Right? If it said less than, then I'd want to shade the stuff that's below the line. Right? So when you do it this way, then you don't have to, you know, do any like test points or anything like that. You can just see that it's going to be this side. Okay? But remember that this dotted line means that any points along this line are not included in my solution. Right? Just all of the stuff. So if I was to pick a point over here like negative 1, 1, right? And if I put that point, that negative 1, 1, I just made there, in place of my x and y, right, then I'd have 6 times negative 1 minus 2 times 1, right? Since this is on the shaded sign, that means I should get a true statement here when I do this. So I get negative 6 minus 2, right, is less than 12, so that's negative 8 is less than 12, and that is a true statement, right? Negative 8 is less than 12. That point is one of my solutions, but it's not the only one, right? Any of the points that are over here are all part of my solution. Right? So that's why when I'm drawing this, I have to shade all of those in because all of those numbers are going to work. Okay. All right, questions on that? All right, what about if we have two lines that were being asked? So sometimes it's going to ask you to graph the system. All right, so a system of linear inequalities. So let's try this one. So if I have 2x is less than or equal to y, and then my other one is x plus 4y. Actually, I'm going to write it next to each other. Oops. So x plus 4y is greater than or equal to 4. All right, so I wanted to talk about these because these are a little bit different. So we want to have it in the y equals mx plus b form, and you want the y to be on the left-hand side, just to make it easier to do your graphing. And so I want to just make sure everybody sees, like if I was to, move my y over to the other side and my 2x over to the other side, it's really kind of like I'm reading this backwards. So if I'm reading this, I'm saying y is greater than or equal to 2x. Right? So I want to move this so that my y is on the left-hand side. So, because otherwise I'm reading this backwards. Okay, so y is greater than or equal to 2x. And then here, let's solve this one for y also. So I'm going to subtract my x over. And then I'll divide everything by 4. So y is greater than or equal to negative 1/4 x plus 1. All right, what questions do you have on how I got to those inequalities, first of all? Okay, so if you're missing it on the homework, it might be that you have it backwards, where your y needs to be on the left side. Let's see. Just write it right here. So y on left side. Just say it like that. Okay, so we're going to graph this on the same grid, right? And what we're trying to see is where they overlap each other. Because notice this is an and, right? And these are all going to be and statements on these, because we want to know what is the intersection between these, okay? So let's graph both of these on here first. So my first one, I'm going to do an orange. So my y-intercept is 0, right? It's not shown there, so it's going to be right there. Whoops. Click on orange, right? So at 0, 0, and then from there, I'm going to go up to the right one, up to the right one. Okay, and then it has the equal to part, so that means it is a solid line. So it's going to come up like this. Whoa, crazy looking line. Imagine that straight. And then we've got to decide which side of the line is going to be shaded. So it's the stuff that's greater than, right, or equal to. So that means all the stuff above the line, all the stuff up here. Okay. And now we need to do the other one. So I'll do this one in purple. Okay. So this one will start at 1, and then we're going to go down 1 and to the right 4. Right? Or I could have went up 1 and to the left 4. Right? Something like that. And so my line, again, it's going to be solid because it has the equal to part. And I want the stuff that's greater than it. Right? So that means I want all this stuff up here. But then my solution is actually the parts that overlap each other, right? So the parts that are overlapped, I'll just kind of shade here in green so you can see it's just this part in here. That part is my solution. Okay. Wow, it looks like a 2-year-old was drawing on here. But, you can get a draw, so hey, it's fun.
So do we ever have to write that out, or is it just always graphing for that one?
It's always going to be graphing, because there's no way we could write out all of those points, right?
That's what I was thinking.
Yeah.
I don't know if I was crazy.
No, you are not crazy. That would take forever, so we couldn't do that, so that's why it's always going to be a graph. Good question. Let's see, I was going to just have you look at let's look at the assignment really quick because I just want to make sure it's clear for everybody on what you need to do on these ones where there's the two equations. So let's see, right? So if you had something like this, actually, you know what? I'm going to go back to this one and try a similar one here, just because these are already set up in y equals mx plus b form. On number 11, you have to go and put these into y equals mx plus b form first, which isn't too bad, but this will be a little bit easier to show you quicker. So if I do my top equation, right, my y is greater than 4x plus 1. So first of all, you need to pick which, so notice how it defaults to the solid line down here. So I got to select the dotted line first before I start drawing this in. All right, so I'm going to go, my y-intercept is 1, so I'll do my first point there. And then I'm going to go up 4 and to the right 1. Okay, and then I need to decide which side I need a shade. So I just need to click on the one side or the other, right? I want the stuff that's greater than the line, and so that's going to be this side. It's the stuff that is above the line. Okay, and now I'll do the other line. Right, so I've got to click on that, and then it's all ready for me to go to my next line. Again, double check that I, want the dotted line, because that's the one that's still selected now, which I do. I'm going to go down to on the y-axis, right? And then from there, right, my slope is -1 over 2, so I'm going to go down 1 and to the right 2. Right, and then again, I need to decide which side I'm going to be shading. So I want the stuff that's less than the line, so that's going to be the stuff below it. So that would be on this side. And then remember, the part that is my solution is just this kind of reddish purple looking color here, right? That's the only part that is my solution, right? But it shows everything, so you can kind of see there, right? And then if you submit that, you can see, yep, that is the correct answer there. Okay, so just making sure you know how to put things in. Sometimes on that homework, it can get a little bit tricky. Okay,